Today's class I'll be talking about sine and cosine graphs. So sine and cosine graphs. So in your book, the standard equation for the sine and cosine graph is given as a sine bx plus c. This is what's written if in your book. So I'm not going to use this one. I'm going to use y equal to a sine b outside x plus c. That's how I'm going to always keep it. So I'll also recommend you guys to keep it, because this way it was easier for me. But even if you do it this way, if you don't want to listen to this lecture and you're doing it your way, that's great. Also, you can follow the book too. I have no problems with that. But don't do both the methods, because that can complicate the things for you. And then I will also add plus d to this one also. So this will be my standard equation, and also cosine graph equation will be a cos of b x plus c plus d. This will be the cos equation. So if I do draw the sine graph, the sine graph's gonna look something like this, and the cosine graph's gonna look something like this. That's how the cosine graph's gonna look like. Sine graph starts from the zero, and this line, the red line, this is the mean line. And then if this is just a standard graph I'm drawing for sine x. So this is called amplitude, this distance amplitude. And then this is called interval also, this distance where it completes the one cycle. This is called interval, 2 pi, or time period. So if I compare it with the circle, what happens? The circle starts from here, it completes itself within 2 pi, and then this wave also completes itself within the 2 pi amount of time, or it's an interval of 2 pi, shall I say. Now let's compare this equation with the standard equation. So, and we will try and understand all the terminologies which are used in this equation. So y equal to a sine bx plus c plus d. This is the equation. A represents the amplitude, this is amplitude, and b represents, as I said, it represents the interval or time period. You can always find the time period by using the formula 2 pi upon b. C represents the horizontal shift, and d represents the vertical shift. I'm just gonna quickly go back and check whether the mic is working or not. Yes, it is working. So now I'm going to start drawing this equation. So I'm going to compare it first of all with sine x graph. So sine x graph looks something like this, and then it repeats itself over the period of time. Okay, it's a continuous graph. So from here to here, this is the interval. As I said, the interval is of a standard graph is 2 pi, and amplitude, this is in front, there is nothing in front, so it means 1 in front. This amplitude is 1. Okay, so A represents, A will become, if I compare it with this graph, A will become amplitude. And now in this one, there is no horizontal and vertical shift. If I have to write this equation, sine x equation, in in this format, what I'm going to do is I'm going to write 1 sine 1 x plus 0 plus 0. That will be the standard comparison for this one. A sine b x plus c plus d. So a value will become 1, b value will become 1, c value will become 0, d value will become 0. Now, another thing which we need to notice is whenever there is an addition here, for this is, as I said, this is a horizontal shift. This addition means you are moving your graph towards the left hand side. This addition means you are moving your graph towards upward direction. So you can also remember this thing with an analogy of, or with this line, add to x, go west. When we are adding to x, you will go west. When you are adding to y, this is addition to y, you will go high. So add to x, go west, add to y, go high. And opposite to that will be the opposite in the direction also. So if you're subtracting from x, you will go towards the right hand side, graph should move to the right. And if you are subtracting from here, you will move the graph in the downward direction. So I've given you guys the basics. Now I'm gonna try and write down an equation and see whether what kind of a graph we're gonna get for that. So y equal to, if I write 3 sine 2x plus, well, I will write it as 3 plus 2. That's what I'm gonna write it as. Now I wanted to draw this. Okay, I'm gonna skip this plus 2 for the time being, and I'm gonna only draw this one, and then later on we're gonna see it on the Desmos. What does plus 2 also do to the graph? Now this is 3, so amplitude is 3, and then phase shift will be equal to, or time period will be equal to 2 pi upon b. So time period, so which is equal to 2 pi upon 2 in this case, and then this is equal to pi. And then it means, if I try and show these two things, so 3 sine 2x. Right now I'm just showing this thing. I'm not adding this 3 to my graph. That I will add later on. So 3 means the amplitude will be bigger. This will go like this, 3. This will become 3. Earlier it was 1. Now, and this 2 pi means now the time period has become pi. So it will start from 0, and this point will become pi, and the midpoint will become pi over 2, and this point, it will become pi over 4. And then you can also figure out this point also. So you can always add pi over 2 plus pi over 4, multiply this by 2, this by 2. So 3 pi over 4, this point is 3 pi over 4. So that's how you can find out the points of the graph also. Another thing is, now when there is a horizontal shift, so if I'm adding 3 to this, it means my graph will move 3 points to the left. So this point here, if I see x value is pi over 4, and then y value is 3. So this is going to give me a horizontal shift. So horizontal shift means, let me put my laptop on charging. So horizontal shift means you are moving 3 to the left. So from pi over 4, this is pi over 4. If I do the math, 3.14 divided by 4, what is the value for that? 3.14 divided by 4, that is 0.0785, and you subtract 3 from that, so minus 3, that's going to give you 2.215 towards the left hand side. So your new point will be, the top point here will be, again I'm going to draw the graph, and I'm going to draw it like this, and this point will become negative 2.215 and 3, because I haven't done any vertical shift, nothing here. So I won't change the vertical y point, I will only change it towards the left hand side. Now I'm going to try and see on the graph, how does this graph looks like. uh, so let's see our graph on the Desmos. Now, just before I jump onto the Desmos, one more thing which I wanted to tell you. If there is a negative sign, so if the graph is like this, sine x, is the graph gonna look like this. If it is negative sine x, it means there is a reflection in the horizontal axis. So the graph's gonna look like this. So this graph's gonna flip upside down. So something like this, it's gonna go. If I put it as a negative number, so negative sine negative 3 sine x plus, well, here it should have been 2x plus 3. So the graph's gonna turn into upside down if there is a negative in front. So let's, without wasting more time, let's move into the Desmos graphing for our work. So I'm gonna go to the Desmos. Let me change my computer settings so that I can show you guys the Desmos calculator. So here I'm going to share the Desmos. Here I can see all my graphs. So I'm going to start with the y equal to sine x. So this is the y equal to sine x. I can clearly see the phase is starting from 0 to equal to 2 pi. and then if I draw the y equal to 3 sine 2x, how the graph's gonna change. So the starting from 0, the phase has become 0 pi. I can see x value has become 0 to pi, and then let's see whether the amplitude has become 3 or not. So vertical point is 3 clearly, and then this point is pi over 4. That's what we also figured out. And then if I move subtracted 3 to the left, so let's see where the new graph will be. Please do not assume that this green graph is moving toward the right. This actually, from the blue, this will be the new green point, the one which I'm about to draw. This, I think I have to zoom it. I cannot zoom it in. Now I can. So from this blue graph, which was pi over 4 to 3, and I will shift my graph to this point. See, the point is negative 2.15. That's what we figured out. So graphs has moved that much to the left. And if I plus 1, so plus 1, let's see what happens. So the graph moves 1 point to the up. So this point, you can clearly see it has moved 1 point to the up. So this is the strategy you're gonna follow while doing the graphing. So I've given you all the basics which are required to the graphing, and the cosine graph will be exactly the same. All the functions and all the terminology which we talked about will remain exactly the same. So the equation, if I go back and change the computer screen, uh, so whoops, share the application screen. This is the notebook. That's what we are doing the question on. So y equal to a cos of bx plus c plus d. So again, the period, it starts from 1. This is how the graph's gonna look like, and this is 1, and this is again 1, and it's here, and and then this is also 2 pi, and one cycle is completed in 2 pi interval. And you're gonna apply the same thing. If there is a negative, the graph's gonna flip upside down. So I will highly encourage you guys and girls to practice these questions, and also try and solve some of the examples. I'll tell you which questions you can solve from the book, and yeah, that will be more than enough. So I will say page 310. If it's on my book, but your book can have the different page number, I'll say example 1, 2, 3, and 4, these examples. And with that, I'll highly encourage you. So on page 312, exercise 10.1, exercise exercise 10.1, try and solve question 7 to question number 12, 7 to 12. And yeah, and then from 10.2, 10 exercise 10.2, try and solve some of the questions on actually, you can go to directly to 10.3. 10.3, you can solve some of the questions, question 3 to question number 16. 3 to 16, you can try and solve some of these questions. And then if you want to look at the graph examples for these questions, that will be great too. So yeah, so I've given you pretty much everything. Even if you can solve this is more of a standard equation. It will cover pretty much everything from the previous topics also. And yeah, that's about it from my side. And please make sure you mention all these points. So for example, I did mention these points here. This is pi over 4 and 3. This will become this will pi over 2 and 0. This is 3 pi over 4. Well, this is comma minus 3, and this is pi and comma, this will be equal to y value is 0 here. So make sure you mention all the points when you are drawing the a graph and when you are moving it from one place to another. So good luck with this. And if you have any questions, please come and see me in the online tutorial, which I do it on Thursday from 3 to 4. I post the link for that one also. And on Saturdays also in-person tutoring in library. So enjoy your time. I will sign off from here.